We have set V, which gives you your vowels, and then we have set C, which gives you some letters, and then set M, which also gives you some letters. The first one was the intersection between set C and set M. You should have gotten just H and M. 50 was the union between V and C. That means all of them that are in V or C. Any questions on intersection and union? Intersection's where they cross over. Union is all of them between the sets. The next one is asking true or false. A is an element of set M. This was true. The next one, subset. M is a subset of C. False, right? We're missing some letters there. All right, and then it wanted you to draw the Venn diagram of your number set. So hopefully you have seen this. They are all real numbers, natural, whole, integer, rational, and on the other side, irrational. And I will take Q prime or I there for that one. So this section is all about adding rational numbers. We all know what rational numbers are. They're any number that can be written as a fraction. So that's going to be your natural, whole, integer, and rational. All of those fall under the rational umbrella, right? When you're adding numbers, the first method they usually teach you to add is a number line, which is what they actually do here. And so they want us to add these numbers on the number line. You'll notice that these numbers have the same sign. A, they both have the same sign. The sign is positive. B, they both have the same sign. The signs are negative, right? And so you want to think about signs as movement, all right? So you're always going to start at 0, and then you're going to move however it tells you to move. If you look at this first one, we start at 0, and it tells me to move positive 3. Well, on a number line, positive 3 is to the right. What's the next movement? Positive 2. To the right again. This is how we end up at positive 5 because I moved both times in the positive direction. All right. This is common sense. I mean, I honestly could give this to my 5-year-old and say, what's 3 plus 2? And she would tell me 5, right? So I'm not worried about 3 plus 2. Most of y'all hopefully can do that without a number line, right? But what this helps you visually is to start double checking, does my answer make sense? So let's look at -1 plus -3. Very often people don't have problems with this either. Because if you were to look at a number line, I start at 0, I move in the negative direction 1, and the next instruction tells me to move more in the negative direction, 3 more. And most people logically can do -1 plus -3, and they naturally tell me -4. All right? And so same sign problems don't typically cause any issues. For the most part, if you're adding two numbers with the same sign, you can give me the right answer, right? And so what actually is more of a problem is when you have different signs. All right. So if you start thinking about this as movement, then you can kind of say, does my answer make sense when we move on to the rules and we stop using a number line? So we're going to use the number line for these as well. My movement for the first one, I'm moving in the positive direction 3 units. And then it tells me to move in the negative direction 2 units. Logic would tell me if I moved farther in the positive than I did in the negative, my answer should be positive, all right? I go back to football. It is my favorite sport, so this is what I'm going to use, right? We throw the football and we gain 15 yards, but on the very next play, well, let's not say 15 because we'll be on the new down. So we gain 7 yards on the first play, right? And then on the second down, we lose 3. Something would tell me I'm still further away from that first down than I was on that first play, right? Because I gained 7 and I moved back, but I'm still in the positive for the 10 yards that I have to get in my 4 downs, right? I moved 7, I moved back 3, I have 4 yards overall towards my 10 altogether. So that's what the number line helps us do. Let's look at the next one, -7 plus 5. Well, I started 0 and I move in the negative direction 7, and then I move in the positive direction 5. My logic tells me my answer, I am still going to be in the negative, right? And so the number line, while we're not going to really use it as far as I am never going to make you add huge numbers and draw me a number line, I want you to do it so that you understand conceptually. Then when you start using the rules, you can say, is my answer making sense? Did I make answer this question? And it is a logical answer. And if you logically move further in one direction than the other, you should still be on that side of the number line. All right, so we're going to do a couple of these. I want you to do these on a number line. So that means I want you to draw it and I want you to show me both movements. Start at 0, move one way, start from there, and move however it tells you to move. Hopefully you got 6 and 3 here, but let's see how we did it movement-wise, all right? So I started at 0. I went in the positive direction. If you don't see, by the way, a sign in front of it and it's your first number, it's positive. So we're going to go 2 in the positive direction. This is our first movement, and then we're going to go 4 more in the positive direction. You can see you end up at 6. Look at the next one. I started 0. I go in the negative direction 2. That's my first one. And then I am going to go in the positive direction 5. And you can see you end up at 3. I moved further in the positive than I did in the negative. All right? Movement. So if you start thinking of positives and negatives as movement, you will start being more logical in your answers. Now, the rules, though, are really what you're going to use. The rules are what you're going to use all the time. I never draw a number line to add and subtract, to be completely honest. Like, that's not the most efficient way to add and subtract numbers, okay? So the rules are really what's going to help you. And they talk about absolute value, and we're going to talk about it a little bit. I am not going to do the process out like they show it in your book because it's a little bit more confusing. But what you're really looking at is, do my numbers have the same sign or different signs? If they have the same sign, I kind of ignore the sign originally and I just add my numbers. That's why they mean absolute value, okay? So if I have -3 plus -2, I'm not going to worry about the negatives right now because it's the same sign. I'm just going to take the 3 and the 2 and I'm going to add those numbers, 5. And if they were the same sign, then my answer is going to follow that same sign. -2 and -3, that's 5, and it's going to be specifically -5 because I started with 2 negatives, same sign, okay? So when you're adding, if you have the same sign, just add those numbers and keep your answer the sign that those started with, all right? But if they're different signs, you will always, always, always subtract, all right? Because they're going opposite directions. So the overall distance to 0 is going to be the difference of those two, right? Because one is going to negate the other, no matter what. So if they're different signs, ignore the signs at first, just subtract the 2 numbers. Subtract the smaller one from the larger. And then go back to your original problem and say, which of these numbers had the negative? Which was further away from 0? Okay? Which one had the positive? Which was further away from 0? Whichever one was further away from 0, your answer is going to follow that sign because it moved you farther away from 0. And so your answer will follow it. So keep the sign of the larger. Now, when I say larger, I mean absolute value, the larger distance from 0. Keep that sign in your answer. Same sign, add them, keep the sign. Different signs, subtract, and keep the sign of the larger guy. All right? So let's look at the example here. We have -1 plus -3. Are those the same or different? They're the same. So what we're going to do is we're going to add 1 and 3. What is 1 and 3? 4. They were both negative, so my answer is negative. That's all you're doing here. 8 and -3. Same sign or different? Different. So subtract them. The larger number 8 minus the smaller number 3. What is 8 minus 3? 5. Which of those was further away from 0? My positive or my negative? My positive. So my answer stays positive. All right, let's look at the last one. 4 and -10. Different signs or the same sign? Different. I'm going to subtract. My larger one 10 minus my smaller one 4. What is 10 minus 4? It is 6. 10 minus 4 is 6. Which one was farther away from 0? My positive or my negative? My negative, so my answer is negative. That's what you are doing when you are adding or subtracting numbers, pretty much, okay? If you are adding numbers with the same sign or different sign, this is the rule you're going to follow. All right, so let's try some. Number 6, same sign or different sign? So did you add or subtract these? Subtracted. Which one was farther away from 0? Your positive or negative? Positive. So your answer should have been positive 19. 8, same or different signs? So we should have added or subtracted? Added. And then my signs were both what? Negative. So my answer was negative 15. Good deal? Easy enough? All right. So then we're going to throw in everybody's favorite, decimals and fractions. I know. I hear the gasp of joy. All right. So the rules are the same, literally. But you do have to remember your rules for these specific ones, right? Decimals, you add those, you line those up. Fractions, you have to have what? common denominator, which is everyone's least favorite thing to do. I actually love fractions. I would do them all day over decimals. Any day, all day, give me fractions. But life gives us decimals sometimes, so we're going to do these. We're going to do it exactly the same, though. We have negative 112.6 and positive 39.27. All right, so we have these. They are different signs. So my rule is the same. Because they're different, I'm going to subtract. So I'm going to ignore my positives and negatives. I'm just going to say, are they the different or the same? They're different, so I'm going to subtract. So I'm going to take my larger of the two, absolute value-wise, 112.6, and I'm going to subtract my 39.27. Decimal rule. This bottom guy has more decimals than the top guy. What do I need to do? Yeah, I need a placeholder right here. So we're going to put a 0. Doesn't change the number. All right. And then we're just going to do our same old, we've been doing this since what, 4th-ish grade? Subtraction, right? And so we are going to subtract. You have to do all your borrowing, all that good stuff that comes along with it. And we are going to subtract. Borrow 1. 10 minus 7 is 3. 5 minus 2 is 3. Make sure your decimals are lined up and you put him there too. I can't do 2 subtracted from 9, so I'm going to borrow again. 12 minus 9 is, and then 10 minus 3 is 7. All right, so I've done my subtraction. I go back to my original problem. Which one was further away from 0, my negative or my positive?
Negative.
So this answer is going to be
Negative
73.3. The rules are the same. All right, let's look at my fraction. Same sign or different sign? Different. Now, with fractions, sometimes it's not as intuitive as to which one is actually bigger or smaller. The reason it's not is because we're not comparing apples to apples, right? That's why we need a common denominator, all right? So if I say I want a slice of pizza and you have cut my pizza into 4 pieces, or I say a slice of pizza and you've cut it into 8 pieces, those are not going to be the same, right? And so that's all you're doing with fractions. You cannot compare one piece of pizza to the other if they were cut in different amounts. You have different sizes of pizza, okay? And so that's all fractions is doing. We have 32 pieces and we have 8 pieces. Obviously, the 32, if I took a pizza and cut it in 32 pieces, we're talking teeny tiny pieces at that point, but little itty bitty slivers, and I have 3 of them versus 8, and I have 5 of those, right? And so visually, you can start to see a picture that 5/8 is likely bigger than that 3/32, right? But in order to add and subtract these, we need to get them both to the same. Now, they were nice to us. 32 and 8 actually have a common multiple. What is it? It is 32. So I don't have to change this guy at all. This will remain 3 over 32, but I do have to change this one. What do I multiply 8 by to get 32? 4. So that means I have to do that to the top and the bottom. So what is 5 and 4? 20. So I have negative 20 over 32. All right. And so now, once again, you can see I have different signs. I'm going to then subtract and keep the sign of the larger. So I'm going to take the 20 over 32 and subtract the 3 over 32. What is 20 minus 3? 17. Yeah, so I have 17 over 32. Remember, with fractions, you only subtract the numerators. You've already figured out what the denominator is, okay? Now I go back up here. Which one was further away from 0, my positive or my negative? My negative. This answer is negative. And that is my answer. You cannot reduce that particular one. If I could reduce it, I would. All right, questions on decimals or fractions? All right, let's try a couple. So mathematical property is just an identity in an equation or statement that's true for any type of value of variable. And we have 4 of them here. Commutative property. If everything is addition, it doesn't matter what order you do it in. 2 plus 3 is 3 plus 2. It doesn't matter which way you do that. They're the same answer. Associative. As long as it's all addition, my grouping actually doesn't change anything. So order of operations says do grouping first. But if it's all addition, you can group it however you want. It's not going to affect it. All right? Additive identity said if I add 0 to anything, it doesn't change it. Additive inverse says if I add the inverse, -3 and +3, I get 0. Well, that makes sense. If I go in the negative direction and then back in the positive direction, the same amount of spaces, I'm going to end up where I started from, 0, right? And that's all the additive inverse is telling you. So how does this help me when I'm adding? Well, this helps me to add quickly. If I look at this next example on the next page, I have these 2 problems, -1 plus 5 plus -3 plus -7 plus 4 plus -6, all right? Now, I could definitely go back and forth. -1 and 5 is 4, and then 4 and -3 is 1, and then so I could so on and so forth. I could do all of that. But sometimes it makes more sense. I just did the rule that if they have the same sign, I just add them, right? And so if I were to do this problem, I would group all of my positive numbers and I would group all of my negative numbers. We're adding it, so it doesn't really matter. And so that's how I would do this problem. I would say, well, I have -1, so I have that guy, plus I have -3, plus I have -7, plus I have -6. Those are my negative numbers. And then for my positives, I have 5 plus 4, right? Well, why does this make it easier? Well, I can add these guys up and I would actually rearrange these as well. In my brain, I would go 3 and 7. Why do you think I would do those first? Because it's going to get me to 10, and then I have 1 and 6, so this is going to be 17, right? So I can do it a lot quicker when I start pairing up things that I know add up to 10. All right, and so for all of my negatives, I'm going to end up with a -17 plus my positives, 5 and 4. That's obviously 9. Now I just have -17 plus 9. Different signs. What do I do? 17 minus 9 is 8, right? And my 17 was further away from 0. So specifically, this guy's going to give me -8. That is easier to my brain than going back and forth. All right? And we can do it because of the commutative property. And then I grouped these because of my associative property. It didn't matter that I grouped those and then grouped the others, right? It doesn't matter because it's all addition. Now, if it were subtraction and addition, you would do it a little bit different. You would have to change them to addition. But this is all addition. Look at the next one. So how do you think I'm going to do this? Well, I'm going to say the 8 and the 15. That gives me what? Gives me 23. And -3 and -8. Is this the easiest way to do this? Is that how you would group those? I'm just asking. Would anybody else group that differently? Because I would. Why do you think I'd group this any differently than just positives and negatives? The 8s. Why would the 8s be easier to group? They're going to turn to 0, right? So let's say I grouped it like this, +8 and -8, and then -3 and 15. Let's say I did it like this. This is 0. The identity property says that 0 is not going to change this guy, right? -3 and 15, subtract 12, keep it a positive. So you see why I would maybe group that differently. So depending on what's going on, as long as it's all addition, I can add it in whatever order I want. Whatever makes it more simple. All right? Questions on that? All right. So the reason I group these 2 sections together is because of this very definition here that we're about to look at. Subtraction is defined as adding. Well, that's weird, right? But it's adding the opposite. Always. Subtraction is always adding the opposite. Why does this matter? Well, when you start throwing in positives and negatives, you have rules that deal with addition. Same sign add, different sign subtract, right? Those rules don't apply to subtraction. They apply to addition. Those are rules for addition. And so subtraction is just adding the opposite. 5 minus 3. Everybody can do that, right? That's 2. So 5 minus 3, that is 2. Adding the opposite. That means 5 plus a negative 3. Subtract and keep the sign of the larger. 2. So subtraction is just adding the opposite of the number. This doesn't only apply when you have a negative negative. This actually applies when you're subtracting a positive number as well. All right? And so this helps us then change everything to addition so that we can do crazy subtraction problems. All right? So let's look at this example. This is where you mostly see it, right? Negative, negative. All right? So subtraction is adding the opposite. So I am going to rewrite this problem right here, negative 4 minus a negative 2. I am going to change it to adding the opposite. All right? I changed my subtraction to addition, and I changed my negative 2 to a positive 2. And now I'm going to do this problem. And for some reason, I made this a negative. Just ignore that right there. All right? So 4 minus a negative 2 is the same thing as 4 plus 2, which is easy. What's my answer? 6. All right? Two numbers, same sign. I added. I kept the sign positive. All right, let's look at the next one. We have negative 3 minus 2. I am going to change this guy to adding the opposite. So adding, and what does this 2 become? Not a positive 2, but a negative 2. All right? Same sign or different sign? Same sign. 3 plus 2 is, they were both negative. That is my answer. All right? By the way, this is where I have the most problems with students. Negative 3 minus 2. Oftentimes they'll tell me negative 1 because they don't think about the concept of adding the opposite. There's another clue here. Negative 3 moved me in the negative direction, and the negative 2 moved me more in the negative direction, right? And so your logic skills should kick in and say, I should be further away from 0, not closer, all right? Look at the last one. 2 minus 5. This is adding the opposite. So I'm going to say plus a negative 5. Different sign or same? Subtract. 5 minus 2 is 3. Which one was further away, positive or negative? There we go. So when you have 4 minus 5, you should have gotten a negative 1. Negative 8 minus a negative 2. Subtraction is adding the opposite. That's negative 8 plus 2. Different sign. Subtract. 8 minus 2. My 8 was further away, so I have a... There we go. 7 minus a negative 3 plus a positive. Hopefully we can all do 7 plus 3. You should have gotten positive 10. Questions on subtraction? All right. And again, they want us to do what? Decimals and fractions. All right. My decimals. If I say adding the opposite, then you can see I have different signs. So once again, I am going to subtract, right? This guy's further away, so my answer is going to be what? Positive or negative? My answer is going to be negative, right? Fractions. Once again, adding the opposite, and I still need what with fractions? Common denominator. So what is my common denominator here?
12.
So I multiply both of these by 3, both of these by 4. Keep this negative. Keep that negative, right? And then what do I do? Same sign or different? Same sign, right? So I add negative 8 and negative 9. 9 and 8 give me 17. And just like before, it looks like that. All right, so all right, so they've thrown a few things in here. When I have something like this, I'm going to go through it, and I am really going to change my signs first, all right? There's one little guy that's kind of out of the ordinary here, and it's this one. You see he's in brackets? I would actually change that first, inside to out. So I would change this, a negative and a negative. What is this 7 actually going to be? A positive. So I'm going to do that. So I actually have absolute value of negative 3 minus a negative 4 plus a negative 2 plus 9 minus 7, all right? And so I would actually change those subtractions to additions. So minus a negative 4 is adding the opposite. Minus a 7 is adding the opposite, all right? And then if I want to regroup, I can. This 3 is technically what? Because of the absolute value.
3.
That's a positive 3. So I have 3 plus 4 plus negative 2 plus 9 plus negative 7. So if you want to group them, you can, but I actually see another thing I could group that might be a little easier. What would be an easy way to group this guy?
-2 and -7.
Possibly. So if you want to put all of your negatives together, that's one way. I could put my 3, 4, 9, or I could put my -2 and -7 and just do a final answer. What do these add up to? Positive.
7.
What's going to cancel to 0 with that?
-7.
There we go. So there's another way to group it too. Does that make sense? Does everybody see why I did that? So whichever way you want to do it, as long as you get the same answer, it's good. All right. Some of you may naturally put all your positives together, all your negatives, and just do a final subtraction, right? And some of you may quickly see, oh, well, this is going to be +7 and -7. Group those first. That's going to be 0. And then I just have to worry about this right here. -2 and +9 give me what? 7. 9 minus 2 is 7. The 9 was further away and it was +7. Easy enough. Let's try one.